So now I'm going to talk about the type of van der Waals forces. The first is ion dipole interaction. Now what is mean by ion dipole interaction? First of all, let me decode this word. These two words. What is ion dipole interaction? Ions means something which has charge. It can be cation. It can be cation, which means positive, or it can be anion, negative. Um, or dipole mean which is polar in nature. Dipole means something which is polar in nature. So ion dipole means one is ion, which means whether it has a positive charge or it has a negative charge. It means it can be either cation or anion, and the other thing is dipole, which means polar. It has a positive and negative charges. So let's see the first type of the first type of ion dipole interaction. So let's take example of chlorine. Chlorine, right? Chlorine has a negative charge here. And then we have dipole. For a dipole, for instance, I'm taking hydrogen chloride. This is hydrogen chloride. This is an arrow here. Now what does it mean by arrow? I have told in the previous video. So this chlorine, now I'm telling here again, this is the movement of electron. This is a movement from a region of, because hydrogen is less electronegative and the chlorine is more electronegative. This is the polarity, right? So it has a negative charge. So this chlorine atom, which is negative in electronegative and carries a negative charge, attracts the hydrogen toward itself like this. So the hydrogen gets partial positive charge, and it gets partial negative charge. So this is the interaction between one ion chlorine and the other is polar molecule, right? So this is ion dipole interaction. So let's include an example of one more thing, that how sodium is soluble in water. Let's see how sodium chloride is soluble in water. We can include that example as well. So let's move it. However, I'm dealing with only dipole here. So ion dipole, as you can see here in the picture as well. Let me just explain you the picture, then we're moving. Okay, here sodium chlorine is given. So I'll be making here as well. For example, this is sodium. Let's write here. This is sodium, and it has partial positive, not partial, but it has positive charge, right? Not partial, right? So where are the shapes? Okay, let's see here. I know. Okay, I'll be making myself. I think it's not perfect. Okay, so no, it's not perfect. Let me make myself. Okay, I want a dark color for it. Let's see. For example, this is one water molecule. This is one water molecule, which is tetrahedral shape. That's a geometry of water, and bent is the shape of water. That I have discussed in the previous videos. So this is water molecule. Here, I'm sorry. Okay, so let's take another color for explaining it. So right. So for example, this is a molecule of oxygen which has partial negative charge. It has negative charge, and this is hydrogen which is positive in nature. Electron is more electronegative in nature, due to which it passes positive and negative charge. So hydrogen has partial positive charge and electron has partial negative charge. And same here, I don't need to make it again. Same here, and same here as well. So this oxygen, this sodium atom attracts oxygen towards itself like this, right? So all the hydrogen gets a positive charge, and there is a partial negative charge, partial positive charge, then again the partial positive charge. As we can bring this picture here, so it will be more clear to you. Okay, let me complete it. So I say same here for oxygen as well. Here oxygen and two hydrogen atoms. Oxygen and two hydrogen atoms. In this way, sodium attracts the negative part of the oxygen, which means positive attracts the negative. Positive side of the molecule attracts the negative side of the molecule, right? So this is sodium. Now let's take example of the chlorine. So this is basically a chlorine atom. Let me use it. Let's take an example of chlorine. For example, This is chlorine, which has negative charge. Alright, in this way, the same like here one. Now making less one, very difficult for me to be with each and every part like tetrahydrogen. So this is basically we can say that this is oxygen atom, hydrogen, hydrogen. Let's deal with one and same for the all the molecules, right? So this chlorine attracts the hydrogen toward itself. This chlorine attracts hydrogen toward itself, due to which it gets partial positive charge. Hydrogen gets partial positive charge, partial positive charge, and oxygen gets partial negative charge. In this way, like I have told you, the sodium chloride is soluble in water. Sodium chloride dissolves in water because the sodium attracts the negative part of the water, which means H and OH ions. This is something like this: H plus and OH minus. And chlorine attracts the negative part. Sodium attracts the negative part, chlorine attracts the positive part. In this way, the sodium chloride dissolves in water. So this is basically an example of ion dipole interaction. And let me tell you one thing, that the ion dipole interaction is the strongest interaction. Let me use it and write it here. Then we'll bring this picture here so that I can explain you with the help of this picture as well. So let's write it, that ion dipole interaction is strongest among all the van der Waals forces. Strongest among all the van der Waals forces. Is strongest among all van der Waals forces. Right, these are the strongest among all the van der Waals forces. Let's bring this picture here and let me explain you with the help of this picture. Let's increase the size of this picture. Okay, wait. Let me take an example of this fan. This is basically sodium. It has positive charge. This is oxygen, negative, negative. This oxygen negative attracts the positive, negative attracts the positive, negative attracts the positive. Due to which, for example, this is hydrogen. This is hydrogen. So it's get the partial positive charge. The same for this chlorine. This is hydrogen. Chlorine attracts the positive part. In this way, the sodium chloride is soluble in water. Soluble in water, right? Soluble. So this is basically ion dipole interaction.